Alright guys, so let's continue by talking about this specific polyhedra. Remember that polyhedra is a way of saying polyhedron in plural. So these polyhedra are called the Platonic solids. Why are they called the Platonic solids? Because I'm pretty sure you've heard of this man, in Spanish, Platón. He was a Greek philosopher, mathematician, who did a lot of research about geometrical figures and, well, geometry in general. He These are called Platonic solids because Plato investigated a lot about this and wrote a lot about these figures. These are five special figures that are called either Platonic solids or regular, polyhedra or polyhedrons. Okay, why are they regular? Because they satisfy two conditions. The first condition is that all of their faces are congruent, which means they have the same size and the same shape. And the second condition is that all their edges are congruent. Okay, we can also say that all the vertices are formed by the same number of faces, but the second and the third condition are pretty much the same. So if one happens, the other happens every time that all the faces are congruent. Okay, so to summarize, the polyhedra are regular polyhedra if all the faces are congruent and if all the edges are also congruent. Okay, so we have the tetrahedron, the cube, octahedron, dodecahedron, and icosahedron. Their names are given by Greek prefixes that talk to me about how many elements they are included. In this case, we're talking about specifically the number of faces. So a tetrahedron is a polyhedron, a regular polyhedron that has four faces. A cube has six faces. An octahedron has eight faces. Dodecahedron, do means 2, deca means 10, so this one has 12 faces, and the icosahedron has 20 faces. Okay, until there we're good, right? We can also have, for example, hexahedron. A hexahedron would be hexa, 6 faces. Or we can also have a pentahedron, would be 5 faces. These are all Greek words that you're very familiar with because in two-dimensional geometry you've worked before. Okay, in this classification of polyhedron, remember, we cannot classify any curved figures because these are not polyhedrons. Okay, so only these ones who have flat faces can be classified as polyhedrons. Let's continue with the new set of questions.